Hello, everybody. Welcome to Easy Learn, and today's topic is Pythagoras Theorem. The learning outcome of today's video are identifying the right angle triangle, learning the use of Pythagoras Theorem, the Pythagoras Theorem formula, and a few worked examples. Now, the first very important rule that we must understand in Pythagoras theorem is that it is only used with right angle triangles, that's 90 degrees. And the usage of Pythagoras theorem is that it is used to find lengths. Now, it's used on right angle triangles or 90 degrees. You can check out the triangle right there. That's a right angle triangle. And whenever you're dealing with questions related to right angle triangles, you'll see a little box up there. This box is an indication that it's a 90-degree triangle. You cannot use the Pythagoras theorem on an equilateral triangle or an isosceles triangle or a scalene triangle unless and until you break them into half, turn them into right angle triangles, and that's when you can use the Pythagoras theorem on them. Now, the main thing is that what is the Pythagoras theorem formula? So it's something like this. A square plus b square is equal to c square. The right angle triangles, as you can see, has three lengths. Now, one of them is A, one of them is B. Now, the A and B is basically the horizontal and the vertical length. It doesn't matter what order is the length. You can put the A on the top and the B as your base, but it is very important which one you select as your C, because C is the diagonal length, the one that's opposite to 90 degrees. You can't take a in place of C or C in place of A. The A and B can be reversed, but C cannot go anywhere. The C has to stay where it is. It has to always be opposite to the 90 degrees, or you can say it's the diagonal length. Okay, and this information is very important when you're using the formula. Let's look at some worked examples here. So we have this triangle and the base says it's 5 and the vertical length it says 12, and the one right opposite to the 90 degrees says it's x. So according to the formula a square plus b square equals c square, I'm going to set up these numbers in here. So I have x squared in place of my c square. I'm going to replace the c with the x because my diagonal length is x. So I'm going to write x squared is equal to 12 squared plus 5 squared. Now I could also write 5 squared plus 12 squared. It's completely your wish which one you take as your a and b. But your x square stays your x square. X cannot go anywhere. We have to use it in place of c. Then we solve it. 12 square means that 12 times 12, so x squared is equal to 144 plus 5 times 5 is 25. And then x squared is equal to 144 plus 25, which gives us 169. Now this little 2 on the top, we have to take it to the other side. We need our x only. We have to leave the x alone, or you can say that we need to isolate the x. The x should not have anything attached with it. So because we have a 2 right there, we need to take it to the other side, and this 2 is a square. So when a square goes to the other side, it turns into a square root. So x is equal to square root of 169, and just check that on your calculator. It's going to be 13. So that's going to be your diagonal length, which is x is equal to 13. Let's see another example. Now this time I have 10 as my diagonal length, 8 as my vertical length, and x is my horizontal one. Now putting in the formula again, I'm going to see that now this time my C is going to be replaced with 10 because the horizontal length or the length right opposite to the 90 degrees is my 10, and it becomes 10 square is equal to 8 square plus x square. I could also write x square plus 8 square, doesn't matter, but one of the lengths is missing. One of the A or the B is missing. That's what is important here. Now, 10 square is 10 times 10, which is 100, and 8 times 8, which is a 64, plus x square. Now again, how we did in the last time that we needed our x alone, or we needed to isolate the x. So we're going to repeat the same thing. The 64 has to go to the other side. Now this time, the 64 over here, it's positive. It's positive and it's being added. But when it goes to the other side, the signs have to change. So I'm gonna make another video in explaining the signs and when how the signs change when it goes to the other side. But for now, we just need to know that the sign has to change. So I'm gonna take 64 to the other side, so it becomes negative 64, and then I have 100 minus 64 is equal to x squared, and that gives me a 36. And again, the x squared has to go to the other side, which becomes a square root, and square root of 36 is equal to x, which means that my a is equal to x. That's pretty much it. I hope you liked the video and I hope you understood. You can also write any questions you have in the comment section, and hopefully catch you in the next video, and just like, share, and subscribe. Thank you very much.